Hello and welcome to this week's STEM lesson. This week we'll be learning about volcanoes. What is a volcano? The prime material involved is molten or melted rock that comes from the layer of the earth known as the mantle, which you can see right here. Do you know what magma is called once it reaches the surface? Well, it's called lava. Do you think that all volcanoes are the same? No, they are not. There are different causes, types of eruptions, as well as different shapes of volcanoes. Today, we are going to learn more about the parts of a volcano as well as what makes them unique. And we will learn about what engineers are doing to help predict when volcanoes erupt. The three main types of volcanoes are cinder cone, shield volcano, and stratovolcano. Cinder cones, the most common volcano type, are usually fairly small with steep sides and a bowl-shaped crater. They throw out mostly small pieces of rock near the vent and form a small cone from the buildup of cindery lava, which is burned rock fragments. A shield volcano is formed almost entirely from great amounts of liquid lava. The lava flows out of the vent and slides down the sides of a volcano, making a wide, gentle sloping cone. Mauna Loa in Hawaii is a shield volcano and the largest volcano in the world. Stratovolcanoes have tall, conical shape with very steep sides and look the way most people imagine volcanoes to look. They form during very violent eruptions of lava and rock. Their shape is made of tephra and solidified lava. Mount St. Helens in Washington is one example. Volcanoes are natural events in the life of our planet. Historically, volcanoes have formed all over the earth and have impacted nearby populations. Can you think of any famous volcanoes? When a volcano erupts, there is very little we can do to stop its destructive power. Our best hope is to predict an eruption before it occurs so that people near the volcano can leave. Engineers and scientists build devices that tell us when an eruption is going to take place. Now, some signs that a volcano is going to erupt soon include earthquakes, gas emissions, change in the magnetic field, and the swelling of the volcano itself. Earthquakes begin occurring as magma pushes its way up through the volcano. Engineers use devices called seismometers to detect these earthquakes. As the magma chamber becomes enlarged, signifying a potential eruption, the rock above the chamber gets pushed up, changing the shape of the volcano. To detect a change in the shape of a volcano, we survey the mountain or use devices called tilt meters, which detect changes in the tilt of a structure, in this case, the volcano itself. Other devices measure gases escaping from the volcano as another clue to predicting eruptions. Engineers design and build the instruments to detect these very small changes in the volcano so that people living near the volcano can be warned and evacuate so lives can be saved. Volcanoes usually occur along fault lines that separate tectonic plates that make up the Earth's crust. The typical image of a volcano is a large cone with glowing red lava flowing out of the top. Different types of volcanoes, the cinder cone, the shield volcano, the stratovolcano, they all have different types of eruptions and other unique characteristics. To understand volcanoes, we must first understand what is inside the Earth. The Earth is made up of three distinct layers. The innermost layer of the Earth, the core, is made mostly of iron. The inner core is solid, while the outer core is liquid. Here we have the inner core, then the outer core. The middle layer of Earth is called the mantle, which is this larger area right here. The mantle is a semi-melted layer between the core and the outermost layer, which we know as the crust. The crust is the solid layer on which we live. The crust is much thinner than the other two layers. This thin line is the crust. As we know from studying earthquakes, the crust of the earth is not one solid piece. It is broken into about 15 pieces called tectonic plates. Now, where do volcanoes form? The boundaries between plates are called fault lines. Typically, though not always, volcanoes occur at one of two types of fault lines. One is a convergent boundary where one plate slides under another plate. As the one plate slides under, it is forced down into the mantle where the pressure and the heat are extreme. Under these conditions, the crust melts, forming magma, which is forced up through the crust above it, finally reaching the surface and forming a volcano. Once reaching the surface, magma is called lava. Volcanoes can also form at divergent boundaries where the plates are moving apart. The plates leave a gap where the magma from the mantle can escape to the surface. These faults are usually under oceans and form mid-ocean ridges. Another place volcanoes form is over hotspots. A hotspot is a location in the mantle at which the temperature is abnormally high. In these places, magma forces its way up to the surface, forming a volcano. A famous hotspot is the one that is forming the Hawaiian island chain. The magma from the hotspot forms a seamount, or an undersea mountain, that becomes an island once it is taller than sea level. As the tectonic plate moves over the fixed hotspot, a series of islands are formed. A volcano has many parts. Under a volcano, from a pocket of molten rock known as the magma chamber, hot magma travels up through a fissure called a vent. While a volcano can have more than one vent to the surface, it usually has one central vent. Magma exits the volcano at the crater, becoming lava. The crater is typically a bowl-shaped opening located at the top of a cone. If the eruption is violent, ash and rock are launched into the air. This material is collectively known as tephra. Much of the material ejected from the volcano collects on its side. After many eruptions, enough layers, known as strata, they build up to form a volcano's recognizable cone shape. Explosive ash eruptions from volcanoes can shut down airports, disrupt air routes, and temporarily stop air supply service to remote areas. Some of the equipment that engineers designed to monitor volcanoes help people in the Federal Aviation Administration and airlines make better decisions on flying during volcanic eruptions. Now, thank you for joining me today, and I hope you enjoyed our lesson, and we'll see you again next week.